Okay, welcome to Roasted Academy. Let's discuss the action potentials in a pacemaker tissue. So we know that the heart is made up of two parts, right? It's made up of the contractile system as well as the conductile system. Conductile system, we're simply talking about the electroconductile system of the heart, where we have got the SA node, AV node, bundle of branches, just like that, all the way up to the Purkinje fibers, right? Yeah, so when we're discussing action potentials in this, we discuss them from one, action potentials in the pacemaker tissue, which is the SA node, as well as action potentials in the cardiac muscle cells, the ones that are going to receive the contraction, that are going to contract. So here is the rest membrane potential, right, which is negative 60 millivolts. So it's not really specific because it changes, right? Varies from one individual to the other due to different factors, right? So at 1, funny sodium channels are going to open and closing potassium channels. So these take the membrane towards the positive side. So at 2, there are transient calcium channels. These are of T type, right? They push the membrane to the threshold, reaching all the way up to negative 40 millivolts. Then at 3, there are long-lasting calcium channels. These are of L type channels. These give rise to action potential causing depolarization, right? At 3. Then we know that when there's depolarization, it's going to be followed by repolarization. This is the typical definition of an action potential, where potassium channels are going to open and there's going to be closing of calcium channels of L type, right? So potassium will start to leave the cell, and in the end it will cause hyperpolarization, right? We know that the cell is more permeable to potassium. So this same thing will take place, right? Will continue taking place all the way up to when you observe all these waves here that you can see. So again, funny sodium channels open, closing of potassium channels, T type channels open, pushing the membrane to threshold, the long-lasting calcium channels open, giving rise to an action potential which causes depolarization, then opening of potassium channels, and potassium starts to leave the cell, causing hyperpolarization.